Hi, today we're going to be going over chapter 3.2, linear versus nonlinear functions. And so here we already have a few examples of what's linear. The very first one over here, this is linear, a straight line. This is nonlinear, we have a curve. We have a curve over here, so nonlinear. Our main question today is, am I able to go ahead and identify the difference between a linear versus nonlinear equation / function using a graph, using an equation, or using a table? So the first thing we're going to do is we're going to go over examples of what a linear equation may look like. The key takeaway here is that you must have an x variable in your equation, and the highest power your x variable can be is a degree of 1, meaning that we have a degree of 1. So we have, anytime you have a variable, again, assume there's going to be an imaginary 1 there. If you have an imaginary 1 there, this is going to be my highest degree. So again, that degree means what's the power? Here, all my x variables have a degree of 1. And so these are examples of linear equations. Also, anytime you have y equals a number, that's also going to be a linear equation right there. So again, some key takeaways on how to identify by looking at an equation. Here, this is an example of a graph. How can we identify a graph? So again, a straight line. Over here, we have a positive trend. From left to right, we're going up, so it's positive. From left to right, we're going down, so it's a negative. So again, an equation we covered. Now this is a graph of linear equations / functions. These are going to be examples of nonlinear equations. So again, nonlinear meaning that the x power is not 1. The x power can be a degree of 2, in this case, 4, 3, or we have exponents of a variable, we have radicals, or we have the x on the denominator. These are all examples of nonlinear equations. You can always use Desmos to go ahead and graph these, and then it'll tell you if it's linear or nonlinear. So again, these are equations of not linear functions. So what you do here is you find the differences between the x values and the y as if x changes here. If the y changes at a constant rate, then it's linear. So a constant rate is we're going up by 3. 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 So this is going to be a constant rate of change, so it's going to be linear. Find the difference between x values and as x changes. So as x changes, meaning that we go from x value of 0, 1, 2, and 3, and 4, x is going up by 1. What's happening in my y values? We're going up here by 1. What's happening between here? We're going up by 3. Over here, by 5. Over here, by 7. So this would be nonlinear because we have a non-constant rate of change. Take some time to go over why this is nonlinear here. As x is going up by 1, we're going up by 4 here. We're going up by 6 here. We're going up by 8 here. So you can see that we're going a non-constant rate of change. Over here, we're going up by 4, by 4, by 4, and by 4. So again, some takeaways. Feel free to practice these over here, C, D, and E, to understand why they are linear and why some are nonlinear. Our final slide is going to be talking about domain and range, discrete domain and range, and then continuous domain and range. Discrete means we have individual dots. Okay, that means that the domain here would be at those exact coordinates. So you would ask, what's my domain here? Well, first of all, let's say this is going to be discrete. This is going to be continuous. You would say, what's my domain? My domain is going to be how wide it is. So it's going to be from the x value of 0, so 0 to, this is going to be 6 over here, so we would say that x is going to be greater than or equal to 0, but less than or equal to 6. My range is how tall it is, so you would say, well, y is going to be between these 2 points, so y is going to be greater than or equal to 0, right, the lowest point, and it's going to be less than or equal to this point over here, which is 5. Over here, discrete, your domain and range would be each individual point. So my domain would be all my x values. So my x value here would be 0, 1, 2, 3, 4, 5, and then 6. Again, every single little point there, that would be my domain. My range would be every single y value. So I would start over here. That would be at 0, 1, 2, 3, 4, 5, and then 6. So again, individual x values, individual y values when it's discrete. Over here it's continuous, so it includes all the x values between those 2 points. So I hope this was helpful. If you have questions, please go ahead and